All right, if we asked you to factor 2x squared plus 5x plus 3, we are looking at a basic trinomial. We're just looking at the very basics of how to use a generic rectangle and diamond problem to factor this trinomial. I've got my steps over here on the left, so if you need to write any of this down, you can copy those out to study those. But if I'm looking for just factoring this basically, we're going to get into it completely in a moment. I'm just going to start with step number 1. Draw a generic 2x2 rectangle and diamond problem. And I've color-coded my steps so you can see that as I go ahead and I draw this 2x2 generic rectangle and my diamond problem, it's in white. All right, I'm going to switch my colors now for step 2. Step 2 now says, fill in what you know. We know that the x squared term always goes bottom left. We know that the constant goes top right. And if I multiply these two numbers, I get the product of my diamond problem. 2 times 3 is 6. That is obtained by doing 2 times 3. Multiply the two numbers to get my product. I also know that the coefficient of my x term is my sum. All right, so I know that 5 goes down there. All right, so that's what I'm looking at. That's where those pieces came from. I'm going to erase those just so that we, well, no, I'll leave them up there for now. Let's just change our colors, go to the next one. All right, so now we want to complete the diamond problem. Well, what multiplies to get 6 but adds to get 5? Well, if I know it's a positive 6, I know they're the same sign, and I know that since it adds to get a positive 5, these two numbers must be positive. And although you might see it in your head, I'm going to run through the gamut of options. 1 times 6 is 6. 1 plus 6 is 7. Doesn't work. 2, I go to 2. 2 times 3 is 6. 2 plus 3 is 5. And that works. If you're struggling with that, use your calculator. Just do the product divided by 1. Then the product divided by 2. And you would continue. So I would do 6 divided by 1, 6 divided by 2, 6 divided by 3, and I continue that process, ignore any decimals, but then look at the result that you got on the side of the calculator and see, does that partner make your diamond problem work? It's important you have a systematic approach to that, because if you can't find one because it doesn't exist, then it's what this trinomial would be unfactorable. And that's what we refer to as prime. Prime numbers are when you only have two factors, 1 and itself. Well, a prime trinomial is when you only have two factors, 1 and itself. You can't break it down into two factored groups. All right, in this case, we see that 2 and 3 work. I take these values from my diamond problem and I use them to fill in my X boxes. All right, sorry, it's not Xbox One or Xbox 360. It is just the X boxes in our generic rectangle. Now, once I fill that in, now I want to come in and I want to pull out the GCF in my rows and columns. I want to look right here and ask myself, what do 2 and 3 have in common? What common factor goes into both 2 and 3? Well, 2 and 3 are both prime. The only common factor they have is 1. 1 goes there, and since this is positive, this is also positive. Let's look at the next one down here. All right. What about between 2x squared and 3x? Well, once again, you see that as a 1. All right, 1 goes into it. But we also see they both have x's. Now, our first one, 2x squared, has 2 x's. However, the second one only has 1. So what do they have in common? They have 1x as a common factor, making my side x plus 1. Now, once I've done that, now I want to look at my columns, up and down. And I'm going to try and find what is the GCF of my columns. Well, between 2x squared and 2x, 2 goes into both of those, and x. And I'm going to double check to make sure that that works. 2x times x, does that give me 2x squared? Yes, it does. All right. Then I'm going to check 2x times 1. Does that give me 2x? And yes, it does. All right, so I can go to my next one. What is the GCF between 3x and 3? Well, 3 goes into both of those. And since this was positive, this will be positive. Once again, double check your math to make sure that 3 times x gives me 3x. That's what we'll look at. 3 times x is 3x. Also double check that 1 times 3 gives me 3. And that works. It is true. And therefore, I know that my factors that I pulled out are correct, and I've got my correct dimensions. Your last step, once you've done all that, is to then simply write your factors. Your factors are the sides. So in this case, x plus 1 is one factored group, and 2x plus 3 is the other factored group. And that would be my answer. That would be the factors to the trinomial 2x squared plus 5x plus 3. It wouldn't matter if you wrote it in a different order. You could write 2x plus 3 times x plus 1. Multiplication is commutative. And so the order in which we write these groups doesn't matter. But inside the groups, you should write your x term first to keep it as an order of degree. All right, let's take a look at another example. This is 814, but modified. It's not the actual one that they give you in 814. I wanted to add in a negative here so you could see that. Notice again, I've got the same color coding so that you can follow through the steps as I go through factoring 6x squared plus 7x minus 20. Step number 1, draw your generic rectangle and your diamond problem. So I'm going to draw my 2 by 2 generic rectangle and my diamond problem. Step number 2, fill in what you know. X squared term goes bottom left. Constant term goes top right. I can multiply those two in order to get my product, negative 120. All right? And then my constant for, my coefficient of my x term, 7, goes on the bottom there. That's what I know. Now let's complete my diamond problem to find my missing values. And I wanted to bring in here my graphing calculator so that you could see how we can do this. We're struggling here because we know that 120 is a pretty big number, and I don't know what multiplies to get 120, but adds to get 7. So I start by looking at the negative 120. That tells me that one side is negative, one side is positive. Therefore, when I combine these two, I'm actually looking for a difference of 7, because two numbers that are opposite signs will actually cancel each other out and get a difference. And I know that this number here on the right, the positive number, is greater. How do I know that? That's because there are 7 positives left over. That means there's 7 more positives in these two numbers than negatives. With that information, I can go to my calculator, all right, and I can just simply type in my product of 120 and hit divide by 1 and hit enter. All right, and notice what I see there. I see I've got 1 being what I divided by, and 120 is the result. I look at those two numbers, and I ask, do those have a difference of 7? No, 1 and 120 do not. So I go down to 120 divided by 2, and I hit enter. 2 and 60. No, that doesn't work. Those are 58 apart. So now I do 120 divided by 3. And I keep going. Those are 37 apart. 120 divided by 4. All right, getting closer. All right, those are 26 apart. 120 divided by 5. All right, 24. Those are 19 apart. 120 divided by 6. All right, those are 14 apart. Getting closer yet. 120 divided by 7. If I get something like this, that's a decimal. Ignore it. It's not that. I just go to the next one. 120 divided by 8. All right, and that's 15. Those are 7 apart. So I know my answer's 8 and 15. And I can come back and I can plug this in, knowing that 8 was my less and 15 was my greater. Now, just to pause on completing this problem for a second, how would I know when to stop using a calculator like this? How would I know if something is not factorable? In other words, how would I know if the trinomial is prime, meaning it doesn't have any factors other than 1 in itself? Well, that means that I would just keep going by dividing by 9. All right, and I notice that they're getting closer and closer. 120 divided by 10. Now they're only 2 apart. 120 divided by 11. And at this point, I can now see that my second number, the number that I got, the result, is smaller than the divisor, the number I divided by. That's when I know I've tested all the possibilities. If you've tested all the possibilities and none of them fit what you need, then you know it's not factorable, and therefore you know that the original trinomial is prime. In this case, these ones work, negative 8 and 15, so let's plug those in to our missing x boxes. And it doesn't matter which one we put where. Step number 4. All right, 4, I'm going to pull out my GCF now. All right, so I'm starting off by looking at my rows. I'm going to ask, what is the common factor between negative 8 and 20? Well, it's going to be negative because that 8 is negative, and 4 is the largest number that goes into both 8 and 20. Look at my next row right here. What is the common factor, the greatest common factor between 6x squared and 15x? Well, that's going to be 3x. And then I look at my columns, my first column right here. What is the greatest common factor between 6x squared and negative 8? All right, well, that's going to be 2x. All right, and then I look at my last column there. All right, what is the greatest common factor between 15x and 20? Well, it's going to be positive because that 15x is positive, and I see that 5 goes into that. And just double check your work. All right, 3x times 2x is indeed 6x squared. All right, 3x times 5 is indeed 15x. 2x times negative 4 is indeed negative 8x. And 5 times negative 4 is indeed negative 20. All right, that's what you want to check. Verify that it all works out to make sure that you didn't mess up. Now the last part, just go ahead and write your answer. Just take your sides, 3x minus 4 and your base, 2x plus 5. Write them as two groups. Make sure those groups are next to each other. It would not be correct if they were not next to each other. All right, for those of you who like my little boxes, I did a little bit of a different one that time, so enjoy.